Hello everybody. Today I can put logarithms into exponential form by cycling, starting with the base. So we're going to learn about what the cycle is. It's very important when we're dealing with logs. I can put logarithms into exponential form by cycling, starting with the base. So here's how the cycle works. I start with the base. And this is based on what we learned in the previous lesson in evaluating logs. So basically, we learn that this is saying 4 to what power is 256. So the answer is over here. So I'm starting with the base. The 4 to this power must equal this. So to put this into exponential form, it's 4 to the 4th power equals the answer. If you draw these arrows in and you start with the base, this is really pretty simple. I start with the base. The base of the log is the base of the exponent. I'm gonna write that because that's very important in order to help keep you organized. The base of the log is the base of the exponent. So the base of the log is x, so that's the base of the exponent. The x to the 5th power equals k. And that's it. That's all I'm asking you to do here is to put it into exponential form by doing this cycle. 12 to the -2 equals 1 over 144. We start with the base and we cycle to the other side and then we cycle back. Why don't you try number 4 on your own? I'll give you about 15 seconds to do that. Okay, start with the base and cycle 2 to the p power equals 1 over q. Little hint for 5 and 6, if there is no base written for log, it's a base of 10. And for ln, the base is e. So why don't you take about 30 seconds and put 5 and 6 into exponential form. Okay, if you need more time, you can pause. To put into exponential form, I cycle starting with the base. So I like to circle the base. The base to this power equals that. 10 to the 2nd equals 100. The base to this power equals that. E to the x equals 50. Now, I'm intentionally giving you some ugly looking ones, but it's the same exact procedure, it's just they're a little bit uglier looking. The base to that power equals whatever comes here. So this one would be x plus 2 to the 4th equals x squared minus 5x plus 4. It's whatever the base is to whatever the right-hand side is equals whatever comes after the base. So why don't you try 8 through 12 Why don't you try 8 through 12 on your own? So please pause it. Then I'll go over a couple of them, and then we'll move on to the back the other direction. So pause it, try 8 through 12. Okay, now that you tried 8 through 12 on your own, base, always starting with the base, cycle to the other side, equals the answer, 3 to the x plus 7 equals x squared plus 4. I'm just going to go over one more. This one has no base, so it's a base of 10. 10 to the 4th equals x cubed minus 7x. Okay, I guess I'll do one more. Again, we're always starting with the base, so I like to circle the base, and I cycle starting with my base. The base to that power equals that. So x minus 9 to the x plus 1 power equals 2. Let's take a look at the other direction now. The other direction is definitely not as important, but we'll talk about it. Why not? So if I want to go from exponential into logarithmic form, again, I'm going to write the same thing I wrote before. The base of the log is the base of the exponent. And as long as you remember that, then both directions should come pretty nicely. So the base of the exponent is 9. So the base of the log is 9. The exponent is what it's equal to. Logs from the first lesson, from evaluating, the answer is the exponent. So the exponent always goes on the other side, and the 81 gets filled in there. The base of the exponent is x, so the base of the log is x, and the exponent is what the answer is. So I just kind of fill in the Q. The exponent is always alone on the other side. That's what logs are equal to. They're equal to whatever the exponent is. Base of the log is the base of the exponent, so the log is base 6. And again, the exponent is always what it's equal to. So I would get that. Why don't you try number 16 on your own right now? The base of the exponent is 17, so the base of the log is 17. The exponent is always the answer. And that's it. Let's try 19. The base of the exponent is the base of the log. The exponent is the other side. And I'm just going to throw the x plus 2 in parentheses since that whole thing is there. And that's it. Why don't you try number 20 on your own? Again, the base of the log is the base of the exponent. Okay, the base of the exponent is 6, so the base of the log is 6. The exponent is the other side. And that's it. So your classwork/homework is to finish this worksheet. To put into exponential form, you're cycling the base to the other side, the base to the power equals what comes after the log. Your cycle is always starting with the base. The base of the log is the same as the base of the exponent. And to go in the other form, again, you just kind of fill in the values based on the fact that the base of the log is the base of the exponent. And understand that when you're putting it into log form, the exponent is the right-hand side. We're going to be using exponential form, the first half of this, not so much the second half. But we're going to be using this within solving exponential equations, so it is very important. I'm sorry, solving logarithmic equations, so it is very important that you're able to do it. So again, I can put logarithms into exponential form by cycling, starting with the base. The base of the exponent is the base of the log. So going the other direction, that's your key. The base of the exponent is the base of the log. Have a great day.